thank you for joining this lesson. We're going to do a mathematics lesson, and I believe it shall be well. Once you get this link, kindly invite a friend so that we may continue together. Yeah, so I'm going to select a question for this morning, and we go through it together. Yeah, I can see you already joining. That is good and encouraging. I'm going to select a question from one of the serious exams around. I'm having a paper called the SPAC, in brackets, Hotbed of Mathematics, Kenya Certificate of Secondary Education. So I'm going to choose a question in the session 2, whereby we're going to answer it together. Thank you for joining. I can see people are coming in. Soon we're going to settle for a question together. Welcome. You can share the link with the friends. You can just share the link with the friends. So in this paper, I'm going to choose the question 24, which I can see it is from a probability. So we're going to handle it together, and I believe at least this morning people will receive something. I'm going to focus on the question paper very soon. Continue joining and inviting friends. Machine K makes 45% of the biscuits. So this is a company which makes biscuits, and there is a Machine K that makes 45% of the biscuits. Then we have Machine J, which makes 30% of the biscuits. K makes 30% of the biscuits, and the rest of the biscuits are made by Machine L. So we have 3 machines in this case: K, J, and L. It is known that 2% of the biscuits made by Machine J are broken, 3% of biscuits made by Machine K are broken, and 5% of the biscuits made by L are broken. A biscuit selected at random. A biscuit is selected at random. So this is the question we're going to discuss. We're going to draw the probability tree diagram, and that is what we're going to morning, which is probability for this morning. Yeah, so now we can focus on the paper now. Yes, so here is the question I would like us to share and answer together. Machine K makes 45% of the biscuits. Then Machine J makes 30% of the biscuits. The rest of the biscuits are made by L. It is known that 2% of the biscuits made by Machine J are broken, 3% of the biscuits made by Machine K are broken, and 5% of the biscuits made by Machine L are broken. A biscuit selected at random. Part A of the question: draw a tree diagram to illustrate all the possible outcomes and associated probabilities. So we're going to draw a probability tree diagram, of course, to represent this information. So we've been told that machine K makes 45, J 30, the rest by L. So we have three machines here, and that is where we're going to begin from. That is where we'll begin from. So we're going to have the three machines and their respective probabilities. So what we have is a machine K. We also have machine J, and we have machine L. Then K makes 45%. So we will express the probabilities as percentages. So for machine K, we will have 45%, which means 45 out of 100. Let me use a thin pen so that we may not consume a lot of space. So I'm going to have 45% means out of 100. The other machine makes 30%, that is J. So 30% will be the associated probability. Then for L, we will have the rest. That means if we got 45 and 30, that gives us 75%. The rest means the remaining 25% of the biscuits. Therefore, 25% of the biscuits now are made by L. We proceed with a tree diagram. For K, a biscuit can be made by K and it end up being broken or not broken. For J, the same, broken or not broken. And also for the other machine, we can have a biscuit breaking or a biscuit breaking not. Then now with this, we can feed into the brackets the respective probabilities. For breaking, we are told that it is known that 2% of the biscuits made by J, So we begin with J, 2% are broken. So 2%, that means 98% will not be broken. Then we are told also 3% for K are broken. So for K, 3%. So we say 3% they'll be broken. That is to tell you there is a 97% that is not broken. And finally for L, 5% of the biscuits made by L, they'll be broken. So 5% will be broken. And this is to mean that 95% will not be broken. So after illustrating the tree diagram like this, we can list now the combined possibilities. This is from machine K and broken. So we can have K broken, the next to be K and not broken, the next to be J and broken, machine J and not broken. Then we have L and broken. So a biscuit is made by L and it breaks, and also by L and it breaks not. So with all these possibilities, we can now gauge the few questions from this tree diagram. Using the tree diagram, calculate the probability that a biscuit is made by J and not broken. Made by J and not broken. So this is the only probability. Made by J, that means 30%, and which means multiplication. Not broken, 98%. Not broken. So when we multiply these, whereby we are having 30 and 98 divided by 100 times 100, this is going to give us 147 out of 500. This is the probability that a biscuit will be made by machine J and it is not broken. As a decimal, this is going to be recorded as 0.294. Whenever you are solving probability questions, you should note that not all the times that, okay, there is what we call probability space. So whenever you calculate a question in probability, you should have your answers limited to that probability, whether decimals, whether fractions, whether percentages. The possibilities or the probabilities should be below 1 and greater than 0, or 0 at the lowest. So that is what we call probability space, between 0 and 1. So our answer is between 0 and 1. Again, we are finding the probability that a biscuit is broken. A biscuit is broken. Using this diagram, we just want to find the probability that a biscuit is broken. Probability that a biscuit is broken means it can be from K and breaks, J and breaks, L and breaks. All those are probabilities that a biscuit is broken. So it might be probability from K and breaks, or means addition from J and breaks, or, which means addition in probability, from L and breaks. So we can feed now the exact probabilities, whereby from K it will be 45% and breaking will be 3%, or from J, which is 30% and breaks 2%, or finally it might be from L, which is 25% and breaks, which is 5% for that particular case. Therefore, this is the total probability. So we can take the summation, and the multiplication, whereby I'll begin with 45% times 3%. Then I add 30% times 2% plus 25% and 5%. So when we compute this, we're going to get 4 out of 125. So that is the probability as a fraction. We can also make it a decimal, which is not a must. And this is 0.032. 0.032. Then we have now the third case, broken but not made by machine K. Broken but not made by machine K. So it will be broken. It will be broken but from the other machines, in other words. So it will be broken but from K, but not from K. That means broken but from J and L, which means now we just need 30% times 2%, or 25%, that is from L, 5%. So we need the probability that a biscuit is broken but not from K, which means broken and from the other two machines, J and L, and their probabilities are S. And the probabilities are as shown. Therefore, we can first of all multiply. I'm going to respond to the question. I'm going to respond to the question on the screen. I'll give my contact right now. Let me finish computing the question here. 30%, 2%, plus 25% and 5%. This gives us 37 out of 2,000. 7 out of 2,000, which translates to 0.0185. This is the possibility. Those who would like to consult and ask a few questions can reach me through 0704 153 366. So this is the number I work with. Thank you for following.